So talk a bit here about you know um, mathematics. Just something I don't expect you to understand. It's just for my own sake. I'm talking. Maybe one of you will understand. Maybe no one will understand it. What I'm going to say. It's going to be rambling. But some. Um, Some thoughts about lime, about mathematics, like why lime, you know? Um, because. So, first of all, there is the language, right? The language of the liminality, the in between, the liminality. All of these words. I really should have them next to each other. I have a giant list. I have so much notes, and that's why it would be good if I wrote a book about it. But like another one, like a better one, a better book, like a book that is more made to blow your mind. Something like that. Um, if I would do that, then I would. Yeah, it's like even more powerful to do that. As I write the book about lime, if I would do it, there would be a power in simply writing it, in simply understanding it, understanding the words better, seeing the holistic perspective. So, because there's one thing to find all the small connections, there's another thing to make it into holism, a whole. But okay, I said mathematics, right? I told you mathematics because I think that there's something about math, like calculations, like God making calculations. And what does God calculate? So it's a brain, right? An awareness, giant awareness. And from a perspective, this is a dream, but from our perspective, there's no reason to see it like a dream because we don't have proof of anything else. So, in the lack of proof, this is real, this is reality. For us, it's reality. God, somewhere else, is in its own reality, but that's not our problem, it's not our issue. So, yeah. So what does it do? Well, the mind calculates. So maybe you've heard of Fourier transform, for example. So our brain uses Fourier transform to analyze signals. It will find patterns of frequencies. It will make calculations. Some calculations are much easier to do after doing a Fourier transform. And so that's why the brain works like that. The brain also make like logarithmic operations. For example, eyesight is exponential, and so something that seems to be double the brightness, in fact, is like 10 times the brightness. So that's the operation of the logarithm of the made by the brain so that we can perceive better. That's also why stars appear. What did I want to say? Some stars appear as very, very bright, and others, like sometimes only a few stars are visible in the sky, while like you only see one or two, and the other ones are invisible. I think it has to do with the exponential nature of light. Like light intensity is exponential, and so what I'm trying to tell you is that there's a lot of mathematical operations going on in the brain, and as within so without, the bigger brain of everything has the same kind of operations, the same mathematics, the same problems, the same nature, and it does the same Fourier transform. And what I want to say also is that it tries to find a solution to things, solutions to problems, and it finds solutions by iterative solutions. It's like a computer, right? It needs to iterate a solution. So the brain isn't really logical, it is iterative, right? I mean, at least what I think. So these iterations that it makes to find solutions to problems is so the problems are equations, trying to solve equations. As it tries to solve the equations, it uses, I'm just going to tell you what I think. I think it uses the Newton-Raphson method, I believe. I'm just saying. So the Newton-Raphson method is very basic, and so imagine that it uses something else. Well, the basic method of finding a solution should share some nature of a more advanced method to find a solution. There's some nature that is shared. You can analyze the Newton-Raphson way of finding solutions, and you can get a grasp of the problems that that occur in finding a solution. So what's the problems? Yeah, so there are problems in solving equations for the big brain. The problem is when the iteration, it iterates a solution. It makes a little calculation, it starts over, makes the same calculation forever, right? Like this calculation, start from the beginning, make the same calculation. It's an iteration, contrary to logical like analysis, which which is something else. So as it does this iteration, it can get stuck forever in calculations, never reaching a solution. Okay, these points or these areas of undetermined, like where a solution to a problem cannot be found, they will form Mandelbrot fractals within the so how do I say? Okay, so no matter the problem you have, no matter the equation you want to solve, the Newton-Raphson solution will be unsolvable. It will not succeed at places, at certain places, and it will create Mandelbrot areas where it doesn't succeed. This is the issue. And since the big brain doesn't know about the equation, it's trying to solve it, right? It it doesn't know beforehand where these places are. Yeah, it doesn't know beforehand where is the Mandelbrots, where it will get stuck. It doesn't really know if it's stuck or not, so it needs to keep iterating, because it's not sure. Maybe it's not stuck, maybe it will get out of the infinite loop. So these areas have the shape of the heart. The Mandelbrot is shaped as a heart, as a cardioid. And another name for this cardioid is the limacon. And again, we get to the limit, we get to the liminality, we get to Lyme. So what's happening here is that linguistics and mathematics and fractal realities mixing together. Because, yeah, and so what is and so as the big brain makes these calculations, it uses a lot of time at the edge of the Mandelbrot. It tracks the edge of this almost like measuring the length of the shore of England. You measure the edge of something you cannot measure the edge of, and so it uses most of its time to calculate this Mandelbrot edge as it tries to solve a bigger problem. Yeah. So I don't expect you to know what I just told you, but that's it. I think that's why the heart is there as a significant thing, like the Lyme, the cardioid, the limacon, and the more one looks into these things, there's as I'm saying, as I'm trying to explain, it's like the Philosopher's Stone. It's the Holy Grail, and so the more you look into it, the more you just understand, I think, And how can the big brain evaluate the border of this Mandelbrot without loving it? How can it do that? Because yes, there are indeed Mandelbrots in the Newton fractal. It's called Newton fractal. So within the Newton fractal there is Mandelbrot fractals, no matter the polynomial that you want to find a solution to. It doesn't have to be, it doesn't even have to have squared terms in it, in the polynomials that it wants to solve. And so, in general, there's going to be Mandelbrots everywhere, spread out. And since like, what's the nature of being within the Mandelbrot? Well, that's the black hole, the abyss, where you cannot get out. So that's the and the liminalities in between, right? Where a lot of calculation time is spent. Why is time spent there? Well, because it cannot. It's right at the border. Okay. So yeah, that's it. Okay, bye bye.